Okay, so if we recall that we did combine things that look alike, so therefore we could add, only these are additions, so we add those together, which would be 7x, because those look alike, and then we would bring this one down because it has nothing it belongs to, or not another constant, okay? That would be the answer. We're not solving these, we're simplifying. There's no evaluation unless I told you what x is, and I'm not. So this is what we did this year. Okay, now the only difference between this year and next is with the negatives involved. Okay, so that's why I told you look at the sign in front. I've stressed that many times. So let's look at an example, and then we'll go up a notch where we have the distributive property plus this stuff. Okay, so for instance, let's say I have -7 minus 2x plus 8 minus, I don't know, 3x. And I ask us to simplify it. So I want our final answer to be in simplest form. So very clear about this is that we look at the sign in front. So do I have like terms or terms that look alike? If you remember, I have 4 terms here. 1, 2, 3, 4 terms. So let's circle that and circle the sign in front. Until you get used to this, I'm going to tell you right now, it's very, very vital. Okay, those are alike. So let me go ahead and add them. So what's a -2 and a -3? -5, and just bring the x down. So my first term would be -5x. Again, I'm just showing you this written out, just explain. Okay, now, am I allowed to add the -7 and 8 together? And the answer to that would be yes, you can, because they are both constants. They don't have variables. So again, I look at the sign in front, and I usually cross them out as I do them, so to make sure I got everything out of the way. I can put these two together. So a -7 and an 8, who won the battle, good or bad? Good. By how many? 1. So then my final answer is then +1.
Simple.
Okay, so again, the only difference is now we're applying that integer concept. Now, right now, we're just using the good versus bad method, okay? So, let's look at another one. Again, same concept. All right, let's do, really hates me. Okay, number 2, let's look at -3 plus x plus 3y minus 6x plus 1. I want to write it in simplest form. Okay, so does anything look alike here? Now make sure you tell me negative, positive, whatever I'm looking at. What can I circle and I'm allowed to add together? Valerie?
Well, one
Positive 1x and?
and 6x.
Is it 6x?
Negative 6x.
Negative 6x. Okay, good. That's what I can find. So what's a 1 plus a -6? That would be -5x. Done. Out of the way, right? Okay. Now, what else can I combine and put together? There is something else I can simplify. Aiden?
-3x, -3 and 1.
Yep, -3 and just a 1 or positive 1. So that would be -3 plus 1 is a. So I can just write -2. Same thing. And then therefore, do I have anything to go with this, buddy? No, what do? We just tag it along, plus 3y. Do you have to have it in this order? No. As long as this is negative, and that's positive, it doesn't matter. A lot of kids tend to put it in alphabetical order. This is how I would write it. That's the thing. Okay, just do x, y, put it in alphabetical order, and then put the constant at the end. But you can still have a plus a -2, okay, just to clarify. All right, so that is like the basic thing. Just pay attention to your signs. Okay, now, this one's different. So this is now applying the distributive property with like terms. Okay, so this is what we did this year. This is just a general example of what we did this year. So we did like 3x plus 6 times 2x plus, I don't know, 1. Okay, this is what we did this year. No negatives, right? So what did we do last time? Remember that we kind of broke it apart. Like we took care of this first, right? So I would give the positive 6 to the 2x. So 6 times 2x is 12x. And then give the 6 to the 1, which is still positive. So 6 times 1 is 6. And then remember we brought this down and then combine like terms. Okay? That's what we did this year. Okay? The only difference I'm going to throw in there is the negatives. So if you notice now, I'm going to have to use a combination of both of these. Right? It's a combination. So let's look at our first example here. All right, number 1. Let's say, again, I'm just going to start out pretty simple. Let's do here negative 2a plus 6 times negative 3a plus, I don't know, 8. Okay? Just a simple one, just threw a couple negatives in there. So if you notice me though, you see how I'm cutting it right here?
Yeah.
Because if that's a negative, guess what? That's a negative 6. That does matter. Okay, so this one I'm not doing anything with until I get this distributed. So I give the 6 to the negative 3a. So 6 times negative 3a. What's 6 times negative 3? Positive or negative? So the negative times a positive is a negative. And then I'm going to give the 6 to the 8. So 6 times 8 is 48. 48. I don't have to worry about the sign because that's what I'm used to. Now, if you want to put a plus sign here, you can. Doesn't make a difference. What can I combine together is my like term. So do you see that the negative 2a and the negative 18a can be combined?
Yeah.
But we're doing now the good versus the bad situation. Okay? They're all bad, so what do we do with those? We add them, right? So negative 2 plus a negative 18, that's addition, so keep it bad. Negative 28, and then you bring down the other number.
It sounds like negative 28.
Yeah, 28. So again, make sure you are really focusing on, am I multiplying or am I adding or subtracting? That is the biggest thing that I'm going to see errors with. Okay, now let's have a situation where I now have that negative right there. Okay, so number 1, again, this could be a very popular mistake. So let's look at number 2 with a negative here. I'm going to leave this 5 minus 3 times 6 minus 2x. Just again, one step at a time. I could add another term down here, same idea. Okay. Biggest thing is that you are recognizing that is not a positive 3. Okay. You have to make sure that you see that this is just a plain old 5, right? And this goes with this. This is very, very important. That is what I'm distributing, not 3, because that is going to not be the same answer. So we have 5, which is a positive 5. Okay, so leave it alone. I'm not looking at that until I'm done with this. So this is a negative 3 times a positive 6. We just had that one. Okay, now again, pay attention to the sign in front. They're the same. So a negative 3 times a negative 2x. Negative times a negative is a positive 6x. Okay. Now you can throw little plus signs in between there if you want. Not a big deal. The only thing I can add together are terms that look alike. What looks alike here, Gene? What am I actually allowed to add? I can, there is something I can add together. 18 and 5, I can't add anything, I don't have another X, so guess what? This one right here, I just bring down. And then I can add these two together. So who won the battle, good or the bad? By how many? So you can write it like that, or you could put a little plus sign in between if you want, or you could have it flipped around. Again, I don't care as long as the 13 is negative and the 6x is positive. Okay? There's one more. Okay? This is the last one. I just want to make sure we're clear about what to do.
Are we going to the board after this?
Yes.
I want to get them.
Holy moly, right? Not bad, not bad, okay. First of all, I have parentheses in two different spots, and I haven't talked about this first. Is there anything to combine inside of here? No, can't do anything in here, but I can over here. Because that will be the coefficient for this variable. So if you look here, I actually can combine terms inside of here. Can you see that? So I have a -1, or -3 and a -1, which makes what?
-4.
So this is just a -4a, because -4 times a is still -4a, right? Okay, then I have a +5. Now, this is going with this. You see how this goes with this? Okay, if I recall to you that there is a number that's supposed to be there.
1.
It is a 1. So really, it's a -1. Okay? Or you can say, take the opposite of whatever crap's in there. That's all it means.
Oh.
Take the opposite of x, take the opposite of -5. That's all that means. But I will show you the technical way. So this times this would be -1 times, technically, 1x, right? And then a -1 times a, -1 times a -5. -1 times 1 is -1x. Negative times a negative is a +5. What did I just tell you? The opposite of what's inside. Opposite of x was -x. Opposite of -5 is +5. So you also can do it that way. Then we do what we've been doing, combine terms that look like. Apparently I changed my variables, so let's pretend that this is an a. And clearly that won't, we couldn't add those together, could we? But that was my goal. Okay, do my 5s actually cancel out? They do not. Because they're both positive, so that'd be 10, right? And then bad and bad, so I add, so -5a plus 10 is the final answer. The only mistake you're going to make is forgetting a the negatives or not looking at them in the right spot. So again, pay attention to, if this is a negative number in front of the parentheses, make sure you separate your eyeballs, okay? Some of these are gonna be very simple where it's just no distributive property. Some of them will involve this distributive property, and both of those will be on your test. So, like I said, the back here is just a quick review on the half back here, okay? This is just a review of, do I know what the heck I'm looking at, okay? And then up here is this back page is with the distributive property and combining, but the front is just combining like terms. So no distributive here, but distributive on the top here. Okay? You should be able to get this done in class. All right? So, you rather just do this? I think so. Okay, good. I think so. All right, take one pass it back. I'm going to stop my recording here in a second. I would rather you do it on your own and then check your answers as you go. My answer key is already done. I want you to check. Because I am not, this is your review. There is no review. Okay. Okay, so you can do all of these. You have now mastered adding and subtracting integers and also multiplying, dividing integers.
Can I put my mouse away?
Yep, you can erase your board and put your marker away. And then I need to,